Okay. One sec, let me just get everything set up. Okay, so if at any point my microphone isn't working, please let me know. So welcome to the first PSYC337 Exam 1 review. My name is Claire, and I'm a Tomlinson team member. Maybe I've responded to a few of your emails already this semester. So we have a lot of content to get through in only an hour. So if you posted your questions more recently, I might not be able to go through all of them. So just as a reminder, I'm only going to be answering specific questions with the exception of please go over ERP because I know that was particularly confusing for a lot of people. But other than that, I'm only answering specific questions. So I'm not going to go over everything that Dr. Weinberg covered, but I am happy to clarify concepts that you didn't understand. Yeah, so you can keep posting questions if you want, but I can't guarantee that I'll be able to go through all of them, but I'll try my best. And if you need further clarification on anything that I say, you can post it on the discussion board. So we're having another review session on Monday. So if anything that I say is unclear, one of our graduate TAs, Aisla, will be holding that session at 7, so she can help clear anything else up. Okay, so great. Just to start off, I can't answer any questions about what specifically will be on the exam, so you just have to use your best judgment to decide what to study. So I'm going to help you guys review some of the trickier concepts that you had questions about, but so I need to know this for the exam, like what details are important from this thing. I'm like happy to go over that in general to maybe like help clear things up a bit, but I'm not able to tell you like specifically you need to know these things or like from this textbook chapter these are the things you need to know. Yeah, you'll just kind of have to use your best judgment for that. Yeah, and one more thing. Started because there are a lot of questions. I've reorganized most of the questions that have been asked to be roughly in chronological order based on when these topics were discussed in the class. So if I don't answer your question right away, it's probably because I've tried to make it flow better. But it does mean that if I run out of time, I might not be able to question, but I can talk pretty fast, so hopefully we'll be able to get through everything. Great. So first question. Can the terms illness, mental illness, disorder, psychological disorder, psychopathological behaviors, etc., be used interchangeably? So illness obviously is a pretty general term that isn't specific to psychology. But if you hear these terms used in class, they're all likely being used interchangeably to refer to mental illness. I would say, though, that psychopathological behaviors are less specific than the words psychological disorder. So I would say that psychopathological behavior is more like a symptom. Okay, so the professor explained that for the clinical description in the 5 criteria for valid classification, that most people who met criteria for a disorder will show the same symptoms. I'm not sure what this means. So this just means that disorders are groups of symptoms that cluster together. So that doesn't necessarily mean that people who meet criteria will show the same symptoms. It means that disorders generally are characterized by certain symptoms. So for example, in depression, there are 9 diagnostic criteria because these 9 symptoms tend to cluster together and the heuristic of depression, and they co-occur together more often than not. But because you only need to meet 5 of 9 criteria for a diagnosis of MDD, 2 people could have a diagnosis of depression but only have 1 symptom in common. Can you explain the diathesis model as well as the problems with it? Okay, so for this, I have a few slides that I'll be kind of switching back and forth between. Okay. Right, so diathesis is a vulnerability for the development of a disorder, and the diathesis stress model posits that it's the interaction between this underlying vulnerability and the experience of life stress that are likely to produce a disorder. So the problem with this model is that it treats diathesis and stress as categorical. So you have to have both to develop the disorder, as you can see here, if you can see my cursor. And there's also no real specification as to how much of either you need to develop the disorder. So how much of an underlying vulnerability do you need for a stressor to trigger it, and what level of stressor is needed to trigger that underlying vulnerability. Yeah, so this is the vulnerability model. So in this model, diathesis and stress aren't categorical, it's a continuum. So I think there's a pointer. Okay. So in the bottom model here, you can see that even if you have no diathesis, you can still develop a disorder. So you would just need more life stress compared to someone who has a high level of diathesis. They would need less stress for the triggered. And this model suggests etiological heterogeneity, which transitions us into our next question nicely. But first, some people had some questions about a few general definitions, so I'll just go through those to clear that up. Okay. So what is the difference between epidemiology and etiology? So epidemiology is studying the incidence and prevalence rates of different disorders in a given population, whereas etiology refers to what is causing a disorder. What is the difference between etiological heterogeneity and equifinality? So I know that a lot of people were confused about this, so I'll do my best to clarify it and give some examples. Yeah, so they can't be used interchangeably, just right off the bat. But I'll go over kind of in what context you would use either term. Excuse me. So if a disorder is etiologically heterogeneous, that means that it can arise from different causes, whereas equifinality is more the process by which that happens. So you can think of etiological heterogeneity as just being the phenomenon of disorders having different like origins. It's just the fact that that happens, basically. So an example of equifinality would be how many factors can lead to someone developing depression. So someone who's abused could go on to develop a depression, but so could someone who has a heightened genetic load or a genetic predisposition to the disorder. So obviously these are two very different starting points, but they both have the potential to result in the development of depression. And it's basically the concept of different beginnings can result in the same ends. And I found a graphic for this that I thought kind of clarified this a little more. So let me just pull that up. Okay. Right, so I thought that this did a nice job of kind of clarifying what exactly equifinality is and also multifinality. So I think a really easy way to remember this is multifinality is kind of same beginnings, different ends, whereas equifinality is different beginnings, but the same end result. So hopefully that clears that up a little bit. Okay, and I also have a diagram for the next question. Okay, So how does the hierarchical model link to personality? Okay, so here's what the hierarchical model looks like. I've put a line down the middle to separate the internalizing and externalizing disorders because I thought it'd be a little bit easier for people to visualize that way. So if you've taken a personality course here at McGill, you're probably pretty familiar with factor models of personality. And in fact, some of these factors have been shown to map onto certain disorders. So over here on the left, internalizing disorders like major depressive disorder and generalized anxiety disorder are very highly related to the factor of neuroticism or negative emotionality. And that's just the tendency to experience negative emotions. On the right side, you have your externalizing disorders. And these disorders have been shown to be related to extroversion or positive emotionality, as well as disinhibition. And disinhibition is just being characterized by a lack of restraint. So I hope that clears that up a little bit. Okay, what does the comorbidity chart mean that we went over in the first lecture? So this is just an example of comorbidity with major depressive disorder and generalized anxiety disorder. So just know that this is the wrong row that's highlighted here. So we should be looking at the GAD no hierarchy. I mean, you can see 67% right here. So the hierarchy aspect just refers to the fact that older versions of the DSM used to make it so that you couldn't have a diagnosis of MDD and GAD together, which is why this number is so low. Right. So hopefully, I think this is just an example to help you understand the concept better. But if this still isn't clear, you can let me know. Someone was asking about this graphic. So there are a lot of different ways that we can examine mental disorders. And there are a lot of factors that contribute to their development. So there are genetic factors, environmental factors, and then these disorders are expressed in a lot of different ways. And one thing to keep in mind is that a lot of the measures that we have for looking at mental illness are indirect measures like behavior, for instance. And these measures aren't always nicely correlated with each other. And there's also this problem of some psychiatric disorders share some symptoms or some behaviors. So two disorders may have a few features in common, which suggests that there might be another different mechanism that's shared that accounts for this overlap. And this underlying factor or shared mechanism is something that a lot of people think that we should be looking at because it may help to disentangle this web a bit. So yeah, also, again, let me know if it still isn't clear. Sorry, I lost my window for a second. Okay, so the next question was, can you explain the difference between passive-active and evocative gene-environment correlations of intelligence? It's the same example that your book uses, and I think it illustrates the differences between these three types of gene-environment correlations very nicely. So we'll start with passive. So in a passive gene-environment correlation, your biological parents are determining both your genes and your environment. So if both of your parents are really intelligent people, they're passing that on to you, genes part, but at the same time, your biological parents are likely to have a large impact on the environment that you're living in. So your parents having higher intelligence might mean that they also have higher paying jobs, and because of this, they can send you to a better school, for example. So in this scenario, you're passively being influenced by these genetic and environmental factors. So now evocative. You've grown up in school, and because you've inherited your parents' genetics and you're of above average intelligence, you might produce different reactions from the environment that you're in. So maybe you make the honor roll because you just naturally learn more quickly. And maybe because of that, you get put into gifted classes. And then active. So this is also called niche picking. So in an active gene environment correlation, as this hypothetical gifted child, you might be more likely to seek out experiences because of your high intelligence. So you might befriend certain people or select a major in university. And in this scenario, you're selecting your environmental experiences based on your genes, as opposed to passively receiving them or eliciting them from the environment. You can also let me know if I'm speaking a little too fast. I know I have the tendency to talk a bit fast, so I'm happy to slow down. I think there's a chat box. You can let me know. Great, so and now we're kind of getting into the topic of comorbidity a little bit. So someone asked what multiformity means. So multiformity has to do with the concept of comorbidity. So comorbidity is when an individual meets criteria for more than one diagnosis. So for example, they have a unipolar mood disorder and also an anxiety disorder. And specifically, multiformity is a possible explanation as to why comorbidity happens. So maybe disorders express themselves in different ways. So the underlying disorder could be the same, but just be presenting differently, and sometimes in a way that makes it look like another disorder, such that our current diagnostic systems can't perfectly account for it. So in class, Dr. Weinberg gave the example of a person with major depressive disorder who also has panic attacks. So does this mean that they also have panic disorder, or do they just have these attacks in addition to having MDD, and they don't meet criteria for panic disorder? So you can see that in a lot of these concepts, there's kind of this blurred line, and it's really hard to be able to give definite answers for a lot of these problems. They don't really have easy solutions. So the next question also related to comorbidity. What does the concept of shared etiological factors mean? A phenomenon of shared etiological risk factors is just another possible explanation as to why comorbidity exists. So maybe people receive multiple diagnoses because these disorders have the same risk factors. So to give an example, if someone is abused as a child, that might make them more predisposed to developing both a substance use problem and depression, because being abused as a child can contribute to the development of someone had also asked if risk markers and are the same thing. So I rewatched that section of the lecture. It's in lecture 3 for anybody who's curious. And I would say that yes, they are the same thing. And someone also wanted to know the importance of vulnerability markers and what's a scar versus a true vulnerability marker. So ideally, vulnerability markers are potential indicators that someone may be at greater risk for developing a disorder. So if we know that there are some people who may develop depression following a stressful event, then we may be better able to tailor interventions after traumatic events to that population, as opposed to using this intervention on everybody and having it do nothing for a lot of people. So one of the characteristics that a vulnerability marker should have is it should continue to exist even after the episode is ended. So this is where the problem of scars comes up. because you'll also see a scar after a disorder has remitted. A vulnerability marker is something that would exist even before someone develops a disorder. So you should see it even before they show symptoms. So if I think of like a potential example of this in this study with bipolar disorder and the enlarged striatum, that would be something that you would want to see even before someone's disorder had progressed. And I believe that when they compared people who've been more recently diagnosed with those who've been diagnosed later, you saw that in both populations, which suggested that it could be an underlying vulnerability to the development of bipolar. Okay, so I'm going to go back to my slides. Okay. So between categorical and dimensional, which of the two ignores variability and which of the two has arbitrary cutoffs? So this is kind of one answer. So a categorical system ignores variability because it has arbitrary cutoffs. So it's either yes, someone has a disorder, or no, they don't. Whereas the dimensional system preserves more information. So you need to meet 5 of 9 criteria to receive a DSM-5 diagnosis of major depressive disorder. So in a categorical system, someone who meets at least 5 criteria is thought of as being more like someone who meets 9, right? Because they both have the same DSM-5 diagnosis, they both met the cutoff. But in the real world, maybe someone with 4 symptoms and someone with symptoms present very similarly in the clinic. So maybe their only difference is that the person with 5 symptoms also has problems sleeping in addition to low mood, decreased appetite, etc. But they're still put in the completely different categories of depressed and non-depressed in a categorical system. Okay. Okay. Why are cohort designs more representative? Why is it better if the variable is not rare? Whereas in a case control study, it's better if the variable is rare. So in a case control study, it's more useful if the variable is rare because in a cohort design, you're using people who might not necessarily have the diagnosis or who may never develop it. So basically in a cohort design, you're just sampling from a group of people who are all in the same cohort. So they're all experiencing the same life events. If you want to look at a relatively rare disorder like schizophrenia, you might not have enough people in the sample who will ever develop schizophrenia. So I think the prevalence rate, I think it's about like 1 in 100 people. So if you only have 2 people out of your 200-person sample, there's not much that you can do with that. It kind of defeats the purpose of conducting research on schizophrenia, right? But with depression, more of your participants experience a depressive episode over the course of your study, especially if you're conducting it over a really long period of time. So in that sense, it's very useful in providing you with a very representative sample to study. So in comparison, in a case control study, you have a group of people who have a disorder and a group of people who don't have the disorder, meaning that you're able to sample a larger number of people with the disorder that you want to look at because you're specifically seeking them out, as opposed to just relying on chance. So this is kind of in the same vein. So I'm going to be going over patient versus community samples and different types of controls and the problems that come from them. Okay. So patient populations are derived from clinical settings. A big part of this, a big part of why problem is a lot of people who have a mental illness never seek treatment. And in this instance, you're sampling from a population of people who have sought treatment. So the populations are also usually more severe. They tend to have more comorbid diagnoses. They're predominantly female populations. And they usually have a particularly chronic form of disorder. So they're not very representative of your typical person with a disorder in question. When you use a community sample, you get a sense of the disorder, as Dr. Weinberg put it, in the wild. So these cases are typically milder compared to patient populations. And they also tend to be just at the threshold for the, so if they need to meet 5 of 9 criteria, for example, maybe they're just right there. And that can make it harder to give a precise and accurate diagnosis, especially if you're interviewing people in your study with a structured clinical interview. So once you've selected your population, then you have the problem of selecting your controls. Do you want healthy controls or psychiatric controls? So psychiatric controls allow for more specificity. So for example, if you're looking at a vulnerability marker and you want to know if what you're looking at occurs only in people with a certain disorder, you might want to compare. So if you want to know if marker is only in depression, maybe you want to compare it with anxiety and substance use, and you want to kind of narrow down that it's not just generally seen in people who are ill, but really it's only seen in people who have depression. But you also have problems with healthy controls. So you run into the problem, again, of whether you have a truly representative sample that we talked about earlier with patient populations. So how do you know that the healthy controls you're using aren't a specific group of people? So how do you know they're not just a particularly resilient group of people, resilient in terms of they have some characteristics that contribute to them not developing a disorder? So another thing you'd want to do is match your controls on some variable. So the example that Dr. Weinberg gave was with socioeconomic status, but this can also create problems. So she gave the example of matching a group of patients with schizophrenia to healthy controls based on their economic status. But again, you might end up with a healthy control group that's not the best match for your study. They may have other problems relating to things like functioning that may contribute to why you're able to match them on socioeconomic status. And then the final problem is matching your participants on lab tasks. So Dr. Weinberg mentioned that people with psychopathology tend to perform worse on lab tasks. And that raises the problem of creating a task that highlights the deficit that you're looking at. That highlights that the deficit you're looking at is specific. So you don't want your experimental group to perform very poorly on a task you've designed just because generally, like, they're not able to do it, or in the example she gave, they can't use a computer. So you want to make sure that you're able to target something specific and you're not just capturing a global deficit. Okay, so we're going to go to the slides. So can you go over slide 42 in lecture 3 slides? So this is that slide. So I'll give a little bit of a broad overview of twin studies first. So in twin studies, you want to see if one monozygotic twin, one identical twin, has a disorder. Does the other twin also have that same disorder? So what you want to see is if the monozygotic twins are more alike in terms of whatever variable you're studying compared to dizygotic twins. You want to break down and try to figure out what exactly are the contributing factors to this phenotype that you're seeing. So A is the additive genetic component. So how much more alike are identical twins compared to fraternal twins? So how much more alike are monozygotic twins compared to dizygotic twins? And additive just refers to the fact that many genes will contribute to risk for a disorder. So I'll just walk you through the formula very quickly. So the additive genetic component is 2 times the correlation of monozygotic twins minus the correlation of dizygotic twins. So in this example, the correlation or concordance of monozygotic twins was 50%. The correlation or concordance of dizygotic twins was 25%. So you subtract 25%. Well, you'd subtract 0.25 from 0.5, and then you'd end up with your difference of 25%, which you then multiply by 2. And that's your additive genetic component. And R, if anyone is confused, is just notation for correlation. So one problem with this formula is that it's dependent on the sample that you're measuring. So you'll get different results every time you use it because of genetic and environmental variability. So that means that we can't provide an exact heritability estimate for any one disorder. Best case scenario, we're able to give a sort of range for what the heritability might be. Okay, and then in the same vein of twin studies, someone was asking about, but selective placement actually is related to adoption studies, not twin studies. And it's the idea that adopted are being placed in families that have been very, very carefully screened. So Dr. in class was of a family where a parent has schizophrenia and adopts a child. So that parent isn't representative of most people with schizophrenia. So they're probably wealthier, and they also probably develop the disorder later in life. So that's just one issue that can come up when you're doing an adoption study. So the people you're studying might not necessarily be representative of the population for that disorder just because they've been so carefully screened. Okay. For someone asked for anhedonia, are you looking for a decrease in anticipated depression? So I'm not quite clear on what you mean by anticipatory action. But for a diagnosis of major depressive disorder, you need either depressed mood or anhedonia. So you need to have at least one of those symptoms to meet the criteria. And anhedonia is just a loss of pleasure or interest in almost everything that you do. So I hope that clarifies it a little bit. But again, if I didn't interpret your question exactly how you wanted, you can comment on the discussion board, and we'll hopefully clarify that in the next review session. Okay, how would you distinguish between a melancholic episode and a different type of depression that occurs later in life? Would it be based on how the patient responds to different treatments during the different episodes? So melancholia is thought of as a biologically based form of depression. So it wasn't really thought of as being sensitive to stressors, unlike many other forms of depression, which can be triggered by very stressful life events. So it does seem like melancholia responds better to biological treatments, but as with a lot of things in psychology, the data aren't exactly clear. And another distinguishing feature is that their premorbid functioning, meaning their lives before the initial onset of melancholia, is good. And then once that episode remits, they look good again. So you don't see precursors or effects preceding or following it. And that kind of comes back to the idea of it being biological because it's thought of as being endogenous. It makes sense that you wouldn't really see it occurring in reaction to a stressful life event if you're conceptualizing it in that more biological way. What does there's no family history difference and melancholic depression mean? So if a person has melancholic depression, they're likely to have family members who have other different types of depression. So they're not necessarily more likely to have, also have melancholic depression. Okay. What is the difference between chronic major depression and persistent depressive disorder? So chronic major depression is characterized by really long episodes of depression. So these episodes are lasting at least 2 years, and it's very hard to treat because of just how long these episodes are. Persistent depressive disorder is also chronic, but it's considered a milder form of depression, meaning that they have milder symptoms. So maybe in their everyday life, they're not visibly impaired, but because of how chronic it is, it causes a lot of general impairment over a long period of time. PDD also has a very slow, gradual onset, and people who have it often describe themselves as just like naturally having a lower mood, and then every once in a while, their mood will suddenly dip. Or not like suddenly, but every once in a while their mood will worsen because it's a slower onset. So is that a percentage of people who have PDD will meet criteria for a major depressive episode at some point in their life, and that's called double depression. So I hope that kind of clarifies those two a bit. Family correlation and persistent depressive disorder. Someone was asked for supporting facts. So all I can tell you is that people with PDD are more likely to have family members with PDD as well as major depressive disorder. Okay. Okay. Enlarged striatum was said to be a necessary but not sufficient cause for bipolar disorder. Is necessity limited to this particular study, or is this conclusive evidence for the neurophysiology of bipolar? So what we mean by necessary but not sufficient is that, as has been shown by this study, the enlarged striatum has to be there to develop bipolar disorder. So that's not to say that everyone who has an enlarged striatum went on to develop bipolar disorder. But if you're asking if this is true of anyone with bipolar, psychology is rarely so black and white. So I can't really give you a definitive answer like that. But if you're really curious and you're looking for more information, McGill, as students, McGill gives us access to online databases through the library, and you can find a lot of really great publications through there if there's anything specific in the class that you're looking for more information on that we won't necessarily cover. Okay. So could you go over the table that relates the diagnoses of relatives with 1 MDD and no diagnoses? Okay. So this table is showing the rates of disorders in probands and relatives. So the columns, 1 second, the columns are the diagnoses of the probands, and the rows represent what diagnoses the relatives have. And a proband is just the person who's being studied. So one thing that we can see right off the bat is that MDD is a relatively common disorder. So even in people who have no diagnosis, 6% of their relatives will still have MDD. And you can also see that bipolar is more common in the families of people who have bipolar 1 themselves. And this is compared to probands both with major depressive disorder and probands with no diagnosis. So they have relatively the same rates of bipolar 1 and 2 in their relatives. Probands with bipolar 1 are also more likely to have relatives with major depressive disorder compared to probands with no diagnosis. But probands with major depressive disorder aren't more likely to have a bipolar disorder compared to probands. Okay, what should we understand from the McGuffin study? So the McGuffin study was a twin study, and they looked at pairs of twins where one twin had either bipolar or MDD. And then they went and found the other twin. So I think there might have been some confusion as to where these numbers here are coming from. So I've put the formula here at the top of the slides. I'm hoping to get to some more questions. So I won't go through this point by point, but basically, this is suggesting that there are additive genetic components that are contributing to these disorders. And looking at the results, it looks like between MDD and bipolar, bipolar seems to be more heritable than MDD. So that's just shown here. And then someone was asking if this related to maybe people being misdiagnosed and this leading to statistical noise. So some people who have bipolar who haven't had a manic episode yet, maybe they get diagnosed as having MDD. And I think it's a really interesting question, but I do think it's a bit beyond the scope of the course. And so I guess it's possible that there are people included in the MDD group that are actually bipolar and they haven't experienced a manic episode yet. But I can't really give you a definitive answer. And if I'm speaking a bit fast, I'm really hoping that we have a few questions left before I get to the information on ERPs, and I'd really like to cover that before we end. So what are some generalized elements for GAD? So as Dr. Weinberg mentioned in class, a key component of GAD is worry. So if you look over the DSM criteria for GAD, almost all of the criteria mention excessive worry in some form. So not only is the person experiencing excessive amounts of worry, they're also unable to control their worries and is severely impairing their ability to live their life. So let me know if I misinterpreted your question, if you're looking for a little bit more than that, but a very main part of GAD is the worry. Okay, attribution styles. So I have a slide for this as well. So these attribution styles are the result of revisions to the learned helplessness theory that we talked about in class. If you remember the example of the studies with the dogs that were getting shocked, and then later the college freshmen. So external versus internal. Is this happening to me because of something that I'm doing or because of factors in the environment I can't control? So if I apply for a job and I get rejected, for example, is it because I had bad luck? So that would be external, or there were a lot of other qualified candidates that would also be external, or am I just an awful person and I don't qualify for the job at all, and I'll never get any job ever? That would be more internal, the fact that it's my fault. Global versus specific. Is this something that's only happening in this situation, or does it occur in all situations? So the example that Dr. Weinberg gave in class for this was that with a global attribution style, you might think that because one person doesn't like you, then nobody likes you. And then stable versus unstable. So is this something that's true of you all the time? So for example, a stable, very negative attribution would be thinking something like, I'm always an unhappy person and I'm a failure. Okay, so the next question is a question about something in the book. So this is found on page 180 if you're curious. So the quote is, a full manic episode that emerges during antidepressant treatment but persists at a fully syndromal level beyond the physiological effect is sufficient evidence for a manic episode and therefore a bipolar 1 diagnosis. I'm not sure what's meant by this. This is in chapter 8, and it's in the little DSM diagnostic criteria box if there's anybody who wants to follow along. So someone with undiagnosed bipolar 1 may be experiencing a depressive episode. So, because they've never had a manic episode when they present to the clinic, a reasonable course of action would be to put them on antidepressants. But going on antidepressants with bipolar 1 can trigger a manic episode. So if once you stop the patient from taking antidepressants, they're still in a manic episode, then that's sufficient enough to meet criteria for bipolar 1, even though it was originally triggered by the antidepressant. Okay, so I'm going to switch my screen back, and now we're going to cover ERPs and RUP. Okay. So the reward positivity, or RUP, as it's called, is an example of an event-related potential, or ERP. So ERPs are time-locked to something occurring in the environment. So basically, they're occurring because something happened in the environment, like the onset of a stimulus. So the way we elicit this in the lab is using something called the doors task. So people are told to select from one of two doors, and then they're told whether they won or lost money through these feedback arrows. So the RUP specifically seems to have been localized to the anterior cingulate cortex, the ACC, and the striatum. So both of these structures are important in reward processing. So that's kind of a very general overview of what the RUP is, how we elicit it, and where it comes from. So onto the graphs. So for whatever reason, on these graphs, positive is down and is up. So on the x-axis here, we have the time window in milliseconds where the RUP is occurring. And this here on the y-axis is just the channel, so the specific sensor where we're picking up on the RUP in microvolts. So that's just kind of to orient you. So this light gray line here represents the reward response. So this would be you select and then you're told that you won 50 cents. And this black line represents the loss response. And you can see that in the loss response, it goes up a little bit right here. So even though it's going up, it's actually more negative because remember, negative is up on these graphs. So mapped onto a head diagram like this, we're looking at the difference between their neural response to loss and their neural response to gain. So the darker blue this part is, the more negative this difference is. So why is this important? Well, there's evidence that the RUP can appear blunted in individuals with depression. And what do I mean by blunted? Well, so here are two graphs comparing the reward and loss responses of controls to individuals with MDD with impaired mood reactivity. So you can see that their response is less positive. So this green line is just here to kind of serve as a comparison. It's on the same place in both graphs, just so that you can see that the reward and loss responses in these participants is much smaller or blunted. And you can also see these two lines are closer together compared to the healthy controls. So furthermore, if you look at the head diagrams, you can see a really nice difference over here with the controls, right? It's really nice, it's dark blue, but there's not as much difference here in the participants with MDD, and that's representing how close these lines are. So the reward and loss responses in these participants are less differentiated. They look more similar. So there's quite a bit of evidence suggesting that the RUP may be a potential vulnerability marker, something that indicates that someone may be more vulnerable to developing depression. So that was a very broad overview. And we also had a few more questions pertaining to the RUP and specifically at-risk siblings. So I'm going to go over those graphs next. So in this study, what Dr. Weinberg and our colleagues were looking at were siblings. So they identified the proband as whichever sibling had the least amount of positive affect. And what they found was that if you have a larger reward response, so does your sibling. If you have a smaller response, so does your sibling. So I'm actually just going to pull this up really quickly because I don't think I have it pulled up here right now. Okay, just 1 second. Okay, so this is what I was referring to. So what they found was that if you have a larger reward response, so does your sibling. If you have a smaller reward response, so does your sibling. So that led them to the question, is a blunted RUP evident in the less ill sibling? Is this smaller response evident in the sibling who has more positive affect, regardless of whether or not they have any depressive symptoms themselves? So now I'll go back to my slides. Okay, and this graph here indicates that they do. So here, we are not looking at the probands, we're looking at their siblings. So we're looking at the siblings that had the higher amounts of positive affect, right? Because the siblings with the lower amounts of positive affect were chosen to be the probands. So you can see here that the siblings of probands with high positive affect have a larger RUP compared to siblings of probands with low positive affect. So these thick lines are the reward response. So you can see siblings of probands with high positive affect compared to siblings of probands with low positive affect. And there's a nice difference between these two. But what really demonstrates this very nicely is that there isn't really a difference between how they're responding to loss. And if you look over here on the head diagrams, you can see that there is less of a difference between loss response and gain response in siblings of probands who have low positive affect. So here you can see the this nice dark blue area. So that means it's more negative. And that means that the response to gains and losses is very differentiated. Over here, it's more in the middle, meaning that it's less negative, it's more kind of neutral, meaning that the responses to gains and losses are comparable. So they're not really differentiating between gains and losses. So the person who asked this said, from what I understand, are siblings with higher positive affect more different than siblings with low positive affect in neural activity to gain? So it's not that they're more different. Siblings of probands with high positive affect have a bigger loss minus gain difference. But both groups, in both groups, the siblings are responding similarly to how the probands are responding, right? So if your brother has low positive affect, you have a smaller reward response. But if your brother has high positive affect, you have a larger reward response. And this is a regression predicting the neural responses to rewards of the siblings. And you can still predict the siblings' neural responses just based on what you know about the proband, even when you're controlling for the familial nature of the rupee, and when you're controlling for the siblings' symptoms. Oh, and just one final point that Dr. Weinberg mentioned in class. It also wasn't shown to be related to anxiety, and that suggests that it may be a specific deficit, as in something that we see in people that have low positive affect, so like people with depression. And okay. So we are going to finish right on time. I have one last question relating to the rupee, and then we'll wrap it up. So about the rupee studies with siblings, I understand that knowing a proband has low positive affect and low rupee, we can predict that the sibling will as well have low rupee, even though the sibling is not depressed. But then why would we see blunted neuronal responses to reward in someone who doesn't have the disorder? So if someone who remitted from depression shows normal levels of rupee compared to controls. So I believe you're referring to this slide and how here remitted non-melancholic depression looks much the same as the healthy controls. And I really think that the key here is the specifier of melancholic depression. So you can see here in this head diagram that those with remitted melancholic depression still have no difference in the response to gains or losses. So they're still not differentiating between these two, even though their episode has remitted. Okay, and that takes us up right to 8 o'clock. So thank you to everybody who stuck around and listened to the whole thing. If you want to refer back to this video, I believe that you'll still be able to watch it even when this live ends. So I posted the link on my courses. Obviously, that's how you all got here. So feel free to rewatch it, and then you can skip to specific sections. So if you just want to go over the rupee section, you can go over it as many times as you want. Yeah, so in the end, I wasn't able to get to everything there were maybe 2 or 3 more left, but don't worry, you'll get included in the next review session. And maybe if I didn't cover your question, you could edit your post if you're able to, and just mention something like, please cover in the review session on Monday, just so that Aislinn knows that that was one of them I wasn't able to get to. Okay, so thank you again. Feel free to email us with any questions you have, and you can continue to post on the My Courses discussion board. Yeah, good luck on the exam.